So internal energy is an extensive property. The definition of extensive meaning it depends on size. And so there is a typo or an error in this figure from your textbook because this should be 2801 and 5602. It's missing, this is 2000 or 2800 kilojoules per mole, not 280. So that's just numbers missing on the figure. But extensive properties of a system depend on size. So in this sort of imagined scenario, I mean, we don't just have one molecule of glucose here. We have our glucose molecule. We're imagining this represents 1 mole of it. It's reacting with our oxygen to produce for us water and CO2. And there's a release of energy. And so this like initial state of energy, and this is a lower state of energy. This is how we would show it on an energy plot because it's a negative change. If we have 2, again, drawn as molecules, but if we have 2 moles of glucose to start with, the energy release is doubled. Okay? So doubling the size of the system doubles the energy that gets released. What are some other extensive properties? The next slide has a whole list, but any guesses right now? You can just shout them out. Mass, perfect. What else? Volume, thanks, Paul. So, perfect. An important thing to note is that extensive properties will sometimes, you'll be kind of clued in because the way we're going to report units will have per mole right on there, okay? And so this is energy change for every mole, but if we're talking about 2 moles or 3 moles or 4 moles, that energy change will be different absolute number there. Okay. So extensive properties depend on the size or the mass of the system. Intensive properties are independent of size or mass. Doesn't matter how much or how big you're looking at. It's the same every time. So we said energy falls in extensive. Where does temperature go? Intensive, great. I am a different size than someone else in the room, a different size than everything else around us, and we're all at roughly the same temperature, whatever room temperature is in here right now. Doesn't matter our size or shape or anything, temp is intensive. Okay. Volume, we already said, is an extensive property. What about pressure? Someone else besides Lauren. Or just guess. Just shout out a guess, and there's only 50-50, and when you're wrong, I'll populate it on the screen anyway. I feel like I'm getting more extensives than intensives, okay? So pressure is actually an intensive property. We're all at atmospheric pressure right now, okay? The reason that pressure is an intensive property is that it is in a ratio of 2 different extensive properties, okay? So some amount of force, like I can push down on the table with some amount of force, and I can push with more force, okay? So the size of this force is increasing. But pressure is force over area. And so I'm adjusting for what area I am over. And since we all might have a different surface area, the force on us over our area gives us the same pressure, okay? Area is extensive, force is extensive, but these things are going to scale similarly, okay? And so pressure will stay the same. There's a line that pops up that'll say that again. Mass is extensive. What about density? I'm getting both again, okay? So this is another same example as pressure. Density, think about it. Density of water is the same whether I have like a milliliter of water or the whole ocean, okay? Well, salt water is unique. But a glass of water or a gallon of water, and I got it all from my tap. The density of water is the same. And again, it's mass over volume, okay? So it doesn't matter. As I scale it up and get more and more volume, it's also getting more massive as I add more water, and the density itself is not changing. Length is another extensive unit. What about melting or boiling point? It's intensive. These are going back and forth. So melting or boiling points are, again, these are intrinsic properties of the material we're looking at, and it doesn't really matter how much we have. Okay? Again, water should boil at the same temperature whether I'm trying to heat up a 6 quarts of water or a drop of it. Solubility and concentration are also intensive properties. And again, I have some mass of material when I want to calculate concentration, or I have some quantity of molecules going into some volume, and those will scale accordingly. The concentration won't change as I just have more of the same thing at the same concentration. So a ratio of two extensive properties will be intensive because both will scale accordingly with size.